When we return from break, we're going to be talking about polygon angle sum theorems. And to start off our unit, we need to look at some vocabulary. So concave polygon is a polygon with one or more interior angles greater than 180 degrees, like this picture. This angle is more than 180 degrees. A convex polygon, on the other hand, has all of its interior angles less than 180 degrees. Then we have an equilateral polygon, which is a polygon that has all sides of the same length. So notice the markings indicating that they are all the same length. Notice, though, here that the angles aren't necessarily the same size. A regular polygon has all angles equal and all sides equal. So like this one, our markings would look like this, and our angles would look like this. So all of the pieces are equal in size. An equiangular polygon is a polygon whose vertex angles or interior angles are all equal, so all of these are the same size. Then we have some terms we should be familiar with. That's the exterior angle, which is the angle of a polygon formed by extending the sides. The exterior angle right here, it's only one at each piece, or each vertex. And then our interior angle are all the angles on the inside of the polygon. So just to remember, bring back that information for us. Okay. So our first theorem is the polygon interior angle theorem. That basically states that the sum of the measures of the inside or the interior angles of a polygon are the sum of the measures of the interior angles of a convex n-gon or polygon is n minus 2 times 180. That n is equal to the number of sides. So when I know how many sides there are, you plug that in there and you find out what the sum of the measures of the angles are. So looking down here at this first problem, I need to know how many sides there are. So I'm going to start by marking them so I don't recount them. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 sides. So to find the measure of the angles inside of that polygon, I'm going to take 8. I'm going to subtract 2. That's going to give me 6. I'm going to multiply that by 180, and that's going to give me 1,080. Okay, following the same process, if it's 21-sided as opposed to 8-sided, I would do 21 minus 2, and multiply that by 180. That would give me 3,420 degrees for my interior angle sum. If it were 42 sides, then it would be 42 minus 2 times the 180. That's going to give me 7,200 degrees as my interior angle sum. Okay, now you try this one. Pause the video and come back. Did you get 8,640? If not, let's talk about it when you get to class. Make a note. Okay, now we're going to find the measure of one of the angles. So this, what we just did was all of the angles. Now we're going to do one of the angles. So we're going to take that other formula, and there's a corollary to our theorem. It says that if I take the number of sides right here, the number of degrees, and I divide by the number of sides, that's going to give me the number of the measure of each angle. So the measure of each interior angle of a regular n-gon or polygon with n number of sides is 1 over n times n minus 2 times 180 degrees, or this formula, whichever way you want to write it. We're going to use it like this because it's cleaner. So going down here, that formula is written for me. I need to count the number of sides. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 sides. I'm going to divide by it as well as subtract 2 from it. So 9 minus 2 is 7 times 180 over 9 is going to give me 140 as my interior angle. So each one of these angles is 140 degrees. Let's do it like that. Okay? Now, we're going to do it with this shape. This is a hexagon, so 1, 2, 3, 4, 5, 6, yep. That's 6 sides, so I'm going to take the 6 minus 2 times 180. That's the whole number of the sum of the interior angles, and then I'm going to divide it by the number of sides, which is 6. And that's going to give me 720 over 6, which is going to give me 120 degrees. So each angle inside here is 120 degrees. Okay? Now I want you to do this one, so you try. Did you get 108 degrees? I hope you're stopping the video and doing them. Okay, next problem. Now we're going to find the missing angle measures. So to do that, we're going to determine the sum. See, I got this polygon. I have to know what the total measure should be before I can figure out what that measure is going to be. So to do that, I find the measure of all the sums. Find the sum of all the interior angles by using that theorem. And so notice that there are 1, 2, 3, 4, 5, 6 sides. That's where the 6 came from. And then when I multiply that by 180, I get 720. Now I'm going to use that to write my equation. So the total sum of the angles has to equal all of these added up. So n plus 156 plus 122 plus 143 plus 108 plus 110. That's all of the angles there. So then what do? I combine my like terms or simplify. That's going to give me that 720 equals n plus 539. 39. Then I'm going to subtract the 539 from each side. And that's going to tell me that each measure is angle is 180 degrees, the one that's missing. So this is 181 degrees. Okay? So, we're going to try that on these ones. So again, I have to find the sum of these interior angles, so I have to use the Theorem's formula, which is n minus 2 times 180. So I have to find out n. n is 1, 2, 3, 4. So 4 minus 2 times 180 is going to give me 360. So the interior angles add up to 360. So writing my equation out, I'm going to have n plus 37 plus 152 plus 44 equals 360. Simplifying, I get n plus 233 when I add those together. That's going to give me 360. Then I subtract the 233. That's going to give me that n is 127 degrees. So the missing angle right here is 127 degrees. Okay, you give it a try. Pause the video. Did you get that there are 8 sides and that the sum of the angles is 1,080 and that the angle measure is 135 degrees? Great. If not, make a note right next to it that you need some support or you didn't understand. Okay, our last theorem is the Polygon exterior angle theorem. It says that all of the angles of a polygon, the exterior angles of a polygon, add up to 360 no matter how many sides it has. So that makes life really simple. So when I'm trying to find the measure of an exterior angle of a regular polygon, that's key. The fact that it's a regular polygon means all the angles are equal. So then I'm not having to figure out what each piece would be. They're all the same. With that information, I'm going to take my 360, which is the total of all the exterior angles, and I'm going to divide it by 12. That's going to give me that each exterior angle is 30 degrees. Now, because remember this is what the theorem just said. So I have a 24-gon or a 24-sided figure. Its exterior angles add up to 360 degrees. So I'm just going to divide 360 by 24. That's going to tell me that each exterior angle is 15 degrees. Okay, you try this one. Did you get 8 degrees? If not, talk to me. We'll look at the formula together. All right, our last problems. The sum of the, this should say interior. The sum of the interior angle measures of a polygon with n sides is given, so find n. Okay, so remember the sum of the interior angles is n minus 2 times 180. And they're saying that the measures are equal to that, so 900 equals n minus 2 times 180. So dividing by 180, I get that this equals 5, and then I'm going to add 2 to both sides. I get that n is 7. So it's a 7-sided polygon. That's going to give me 900 internal degrees. So 144, again, the measure, the sum, is equal to n minus 2 times 180. So to solve for this first step, I'm going to divide by 180. That's going to give me n minus 2 equals 8. Then I'm going to add 2 to both sides. That's going to give me n equals 10. Okay? Now you give the last one a try. Did you get that n is 15? I hope so. I hope you're having a great break. I'll see you when you get back.